Hey guys, this is Professor Janacek. I want to go over a summary of the convergence test. Before we begin, I do want to apologize for my informal notation. I'm going to just quickly jot down a few things about each of the tests, but make sure you understand how to formally work through each of these tests. The first thing I look for is the divergence test. It's a rather easy test to try out. All I have to do is take the limit of the terms of the series. If that is not equal to 0, then the series diverges. But if that limit is equal to 0, turns out the test is inconclusive. And we would have to try another test. So after trying that one, the next thing I'll look for is the geometric series. This one's rather easy to identify. The terms look like AR to the K. If the absolute value of R is less than 1, then the geometric series converges. If the absolute value of R is greater than or equal to 1, then we know that our series diverges. If the series is not geometric, the next thing I look for is P-series. This is another easy one to identify. The terms of the series look like 1 over k to the p. And in this case, if the p value is greater than 1, the series converges. And if the p values are less than or equal to 1, then the series diverges. If it doesn't look like a p-series, then I'll look for a telescoping series. This one's a little bit more difficult to recognize. Usually we'll want to write out a few terms to see if they have that form. Remember, telescoping series, the terms end up canceling each other out. We'll have a subtraction of some sort. So combining terms end up going to 0. Once we've determined that it's telescoping, the idea behind this test is to rewrite the series really as a limit of a partial sum. Again, what we'll typically need to do is write out some of the terms until we can identify the nth term. Once we do that, we'll simply take the limit and see what happens. Does that converge or does it diverge? After going through those 3 types of series, if it doesn't fit one of those patterns, again, I'm looking for AR to the K, 1 over KP, or something that is telescoping. If it's not one of those 3, then I'll try the integral test. For the integral test, we'll take each of our terms and define a function off of that, and then integrate from 1 to infinity of that function. Remember, integrating from 1 to infinity, we'll need to rewrite as a limit, and then simply integrate. If that integral converges, our series converges. If the integral diverges, then of course the series diverges. If the integral test isn't easy to do, some of these aren't going to be easy to integrate. If that's the case, the next thing I try is the root test. Really, the root test is easy to identify. As long as k is only in the exponent, then I'll know to use this one. Just a real quick review of that one. We're going to take the limit as k goes to infinity of the kth root of the absolute value of the terms on our series. If that value is less than 1, then the series converges. If that is greater than 1, then the series diverges. Otherwise, the series is inconclusive. Again, my apologies for the informality here. If k is not only in the exponent, the root test isn't what we'd want to use. We might want to try then the ratio test. This is a good one to use if we have a combination of k factorials along with k's in the exponent. Quick review of that one. In this case, we take the limit as k goes to infinity of the absolute value of the a sub k plus 1 term divided by the a sub k term. If that limit is less than 1, then the series converges. If that value is greater than 1, the series diverges. Otherwise, this test is inconclusive. You'll notice this is similar to the root test. If I don't have k's in the exponent, or I don't have some combination of k's in the exponent and k factorials, the integral test didn't work. I've tried all these other tests. The last thing we're going to try is either the direct comparison test or the limit comparison test. These can be a little more challenging because we do have to come up with a b sub k to use in this comparison. But we will do these comparisons typically with a p-series or a geometric series. Those are the best ones to try. And there we go. A nice quick summary of our tests in the order that I usually try to work through them. I hope this helps. Enjoy!